So today we're going to start talking about math functions. One of the alternate solutions to the assignment I gave you in last lesson to do the finding the decimal places in that practice assignment where you had to find the hundreds position, the tens position, and the ones position without using integer division requires the use of a math function. You had to go out and look for something to make that work. That math function to kind of force that and cheat it is a logarithm. So that's one of the access points that you have within Java is be able to use sophisticated math functions and dictate how to solve problems with those math functions. Java is actually pretty quick at doing math. The other method, of course, is doing the percent division, the modulo division, and then you do have to do an integer division. So if you have something like 800, you would have to do an integer division of 100 in order to get the 8 left over. So you can get the exact place value and eliminate the zeros. So that's, you would do a mod and then an integer division. Those two together would end up giving you individual place values for that. So if you haven't finished that practice, that gives you a little bit of an idea how to go forward with that. So let's dive into the math functions. The first thing you have to do is an import statement. Now, an import statement tells Java to go into a library and pull a section of code. It's essentially giving it a collection of objects and methods that allows Java to perform certain things. You might say, why does Java not come complete to begin with? Why doesn't Java just automatically have all of these things in there? Why do we have to go through the trouble of importing? Like, we have a couple other things imported here. We have the java.io, we have the java.lang.system, we have the java.utility.scanner, and now we have the java.lang.math. Why do we need all these things? Well, there are so many different libraries that if you were to import every single library, your computer would be tremendously slow at that point because you have so much stuff running on. Java is supposed to be light and fast. You only need to import the stuff that you actually need in order to run your program. So we're going to be doing math. So you need to import the math functions. You do that with java.lang.math. Now, math is a very special class. I'm going to tell you a little bit about it in terms of this special nature, but we're going to go into more detail later. It's called a static class, which means, unlike the scanner class, you don't have to create a new object for it. We don't have to do math, new, mather, something like that. For scanner class, we have to do scanner, scan, we could call it happy days if we wanted to, equals new, scan, scanner, blah, 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 system.io. You have to create an object. In math, you don't. It's called a static class. And we're going to learn more about static classes later in the year. But you got to keep that in the back of your head, that the math class is a little different because it's a static class. So these are the math functions that you have to know for the AP exam. Absolute value, exponents, square roots, and random numbers. There are many, 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 many more math functions that are built into Java. We will probably use many other math functions than just this list of 4. But these are the 4 that you have to know how to use for the AP exam. And when I say have to know, you have to know which functions return what kind of values and what functions accept what kind of values. So it's not just as simple as doing absolute value math that you did in Algebra 2. We now have to deal with number types. We have to talk about the kinds of types that numbers can, these functions can accept and the results that they produce. Some of them are obvious, some of them not so much. So first let's talk about absolute value. Your Algebra 1 definition of an absolute value is it tells its distance from 0. That is the Algebra 1 math definition of absolute value. The functional definition would be you just make the number positive. That might have been how you learned how to take an absolute value. Just make the number always positive. but really what's happening there is it's calculating a distance from 0. So we have this little program here, and it says enter in 2 ints. I'm going to get 2 ints. Then it says enter in 2 doubles. And then I do some math here. Math.abs, the absolute value, the difference between x and y. Math.abs, the difference between a and b. Now notice, the first time we do it, we use 3 and 4. The second time we do it, we use decimals. The first time we do it, we get 1. The second time we do it, you get 2.3. Think about that for a second. So you may have noticed that the first 2 numbers are ints. The second 2 numbers are doubles. I didn't tell the absolute value what was in it. I didn't do a different calculation for ints versus doubles, but the absolute value function handled it just fine. The reason it handled it just fine is because it actually is 2 different methods. The absolute value function is 2 different methods, and Java knows which one to use based upon the input it receives. If it's in double mode, it's receiving doubles and doing doubles calculations, it returns a result as a double. If it's in int mode, which means it's doing math and calculations with ints, it returns the result as an int. This is called method overloading. We're going to do much more with this in the future. Again, throwing out vocabulary words as we come across them, and we'll formally define them as we get more into class structure. But this is pretty cool that absolute value can take both ints and doubles. So let's talk about the next one. Same type of setup. We're getting 2 ints, we're getting 2 doubles. We're doing math.pow. Powers. The first value is the base. The second value is the exponent. So when I enter in 2 ints, notice it gives me a double as the result. Whereas when I did absolute value, if I put in 2 ints, it gave me an int. Math.pow, the power function, gives you a double result, even if you start with ints. Now, if I start with 2 doubles, it gives me an answer. That's a double. Clearly, that makes sense. So this behaves a little bit differently than absolute value. Absolute value could accept ints and could accept doubles and would return an int if it was an int, and return a double if it was a double. That's important when you're storing answers, that you know that. Math.pow, the power function, always returns a double, even if it's passed in an int first. Again, it's method overloading, because Java looks at what's being sent to it and has to treat it differently if it's sent ints versus sent doubles. However, the result is always a double. Why does it do it that way? Well, because that's the way it was written. And I know it's not a great answer, but these libraries were written by designers of Java, and they decided to do it this way. Can an argument be made that it should return an int? Sure. You can make that argument that an int and an int should return an int, or there should be a separate function for ints. You can make lots of arguments that way. But it doesn't really matter, because the designers decided to do it that way. That's all. That's the best answer there is. The designers of Java decided this is the way it was going to be. So when you recognize x to the y, this says x to the y. So you kind of have to start getting visually used to that. That says x to the y. And this says a to the b. Next function, square roots. Well, sqrt. That is the name of the math square root function. Notice it gives a double as an answer, whether it receives an int or a double. So again, it's overloaded in that it accepts both ints and doubles. Doesn't care. The result always turns out to be a double. So if we do the square root of 16, we get 4.0, not 4. If we do the square root of 0.49, we get 0.7, which makes sense. So the next one, math.random. At first, this is not going to seem like a very useful function, but it is extremely useful. It returns a value that is somewhere equal to 0, but less than 1. It will randomly, quote unquote, generate a value somewhere between 0 and 1, including 0, not including 1. It includes 0, does not include 1. So you're going to get a decimal, a small decimal. And you might say, well, that's not very useful. If I want to pick a random number between 1 and 10, that's not going to be very helpful. Well, it turns out it is. Because you can do some math to take any decimal number between 0 and 1 and turn it into any range of values that you want. You just have to be a little creative with your mathematics. Before we dive into the math of that and start messing with some algebra there, we need to talk about random numbers in general in computer science. They're not random. They call them random. They seem like they might behave randomly, but they're not. They're called pseudo-random numbers. Computers cannot truly predict random events because they're not random things. If your computer started behaving randomly, you'd be annoyed. If your computer randomly decided to start closing windows, randomly decided to start turning off, and I know some of your machines do that, but that's not because of the computer, it's probably because of your battery or you dropped it. But random behavior in computers is actually discouraged, not encouraged. We don't like that. But mathematically, we can come up with a way of generating a number that seems random using what's called a seed value. We'll talk more about this later. But you could put a value in that give the computer to start a particular number, and that seed value generates a number. If you have the same seed value, it will generate the same series of random numbers every time. And I know it just sounds like I contradicted myself. It will generate the same series of random numbers every time with the same seed value. So the trick is to start with a seed value that is unique, to give you a random set of numbers. A good seed value that I find useful is the clock. You take the date and time, that's always unique. So you always get a nice seed value. Another way of doing random numbers is based upon some type of outside random event. Something that it truly is randomly occurring in nature. Maybe they've used light patterns from camera sources, so they turn on a camera and they just kind of use the random light background noise to help generate that random number. They might use a random occurring particle and just kind of something that randomly bounces back and forth. Something that is truly random in nature to get that seed value that you can then generate. But even if you go to the casino, which none of you should be yet, but even if you go to a casino and they have those electronic slot machines, they're not random. They're designed to pay out at a certain ratio. Let me let that sink in for a second. They are designed to win and lose at a certain ratio. Someone has predicted that. And people go in and they test that. There's a gaming commission that comes in and tests those computers to make sure they're paying out within those ranges. They'll have it run through an infinite loop, at a high speed and do like a pseudo cash system just to make sure it's paying out at the right percentages. If you had a truly random slot machine in a casino, that would be really bad for casinos. Because truly random slot machines at casinos means someone could win on that machine every day, all the time. If it was truly random. That doesn't sound like a good business model. You're really truly taking a game of chance at that point. Casinos operate on the premise that, yeah, they always win. Even if it's a little bit. They always win. And over the long period of time, casinos always win. That's why when you put a casino in a town, the town always makes money. Very rarely do you have casinos go down because of the actual casino. The reason the casinos go down, like the one that went down in Atlantic City, was because they couldn't get enough people there to play the games. But they're not losing money on the games. It's really about getting people in the door. Get people in the door, guaranteed to make money. So be very careful when you're talking about random numbers with computers. They're not really random. They're pseudo-random numbers. So let's talk about our math. When we run this command, math.random, it gives us some awful decimal, which we now need to do some number calculation on. So if I want a number between 0 and 99, well, think about percentages, right? If I have a decimal, 0.33376, and I multiply by 100, that gives me 33. So really, essentially, all we're doing here is converting that decimal into a percent, if you want to think of it that way, and then stripping off the decimal, truncating it. And that gives us a 0 between 0 and 99, but it's never going to actually equal 100. Because remember, it can't equal 1. The only way to get 100 would be for it to equal 1. So the best it can do is equal 99.9999, which will never be 1. It'll be 99%. So the other thing we do is this casting here, this int, to strip off any decimal. So if I take 0.3376555 to blah, 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 multiply by 100, I get 33.657, da, 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 make it an int, and I get a 33. So that's a pretty straightforward calculation. Multiply by this value here by 100. But what if I don't want 100? What if I want to include 1 to 100? Well, if you think about it, by adding 1, it shifts everything over. If the smallest value was 0 and the biggest value was 100, or 99, excuse me, then by adding 1, I make the smallest value 1 and the biggest value 100. That gives me a value from 1 to 100 by adding 1. What if I truly wanted 0 to 100, though, right? Well, that becomes interesting. How do I do that? Well, it turns out this value here that we multiply by is going to be the number of values in the range. And this value here is the lowest number. So I want you to think about that for a second. What if I wanted to get between 0 and 100? Think about that for a minute, and we'll come back to it in a second. So if you wanted to get a value between 0 and 100, you have to include 0 in the range. So that means you have 1 through 100 plus 0. That's 101 different values in the range. The lowest number would be 0. So in that case, we would not add 1. We'd want to just multiply by 100. But suppose we wanted to go so we could include 1. Right? So we can include 0. So by picking the different values, we can come up with different ranges. Take a look at this one. There are 41 different values in the range. The lowest value is -20. But we need to include a spot for 0, so even the max value will be 20. So when you do this calculating, So the highest value we could get is a 41 point something, right? When we subtract off that 20, we get 21 and we throw away the decimal. The highest value we can get will be 20. So I want you to practice this. Let's try to do a range from negative 23 to 238. Okay, so we got to do some math here to figure this out. We need to know the range of values and we need to know the lowest number. So pause the video and think about that. So to get the range, you have to make sure you're including 0. So there's 238 numbers to the right side of 0. Then we have 0, so plus 1 more for 0, plus the 23 numbers to the left side of 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 23. Right? 23 numbers. Okay? So we got to include all those values. When we add that up, we now get 262. The lowest value is negative 23. So let's try our math with that. We know that a random number is calculated from 0 to 1, not including the 1. So really this 1 here gets treated as 0.9999 when we do our calculations. So first we're going to do is take 0 times 262, because that's what the math says, multiply by 262. We get 0. Then take 0.99999 times 1, so we can kind of get an idea of what's going on, what would actually happen. So 262 times 0.99999 would give us 261.999 something, right? If we use enough 9s, it's just more 9s. So 261. Then we're going to subtract 23. So 261 minus 23 should give us our 238. Yes? Double check my math, am I right? Okay. 238. 0.99999. But then we cast it as an int. And when we cast it as an int, we get negative 23. And all of a sudden, this includes the 238. So we get the full range from negative 23 to 238.